Okay, so I wanted to introduce everyone to content security policy today. This is an extra layer in protecting against cross-site scripting. I started looking into it because I saw some issues where we were failing to escape properly on Total Care Health, and it freaked me out a little bit thinking about someone doing like a session hijacking attack or something like that on a doctor. So in that project in particular, a patient who could be pretty much anybody. I mean, it's an employee at one of the companies they've contracted with, but it's not necessarily a trusted user. Provides, for example, information about symptoms that they might have, and then the doctor would view that while they're logged in and with their account on a separate page. So if you fail to escape that, obviously someone could inject JavaScript into the page and attempt to maybe get the session cookie from the doctor or so on. For the particular attack that scared me there, session hijacking, there are other ways to mitigate it. For example, in PHP, you can say, don't let the session cookie be accessible via JavaScript at all. So that's one layer you can put in place. But what we're going to talk about today, content security policy, is an additional layer that's pretty easy to implement. So I've got a little demo application here. And the first step that we're going to see in the demo is no content security policy whatsoever. So we got owned. Someone cornified the page. What happened there? Basically, we've got some user data. This one looks fine. They're not trying to do anything bad. This person's put a click handler into the URL field, so they're sending us a message about cyber. And then this person has injected Cornify into the content of their post. And we were being lazy, and we did not escape any of those things when we were outputting our HTML. So we've got script from untrusted users running in our application. Next step in the demo is just doing a very basic content security policy. No longer owned. The only thing we added was this HTTP header. So you say content security policy, script source, self. So if it's a script that's coming from myself, that's fine. Everything else, including inline scripts, is not okay. So that prevented us from being exploited, but it also broke some things. So we can see, these are the attacker scripts here. They're blocked by the browser. But our jQuery from the CDN is no longer loading, and our own inline script that we've got at the bottom of the page is no longer loading either. So that's not really great. Next step in the process is whitelisting external resources. So we've changed our HTTP header to say it can be script source self or code.jquery.com. So we're allowing both of those. So now jQuery is loaded, our inline script still fails to load. So that's the next step. And then we can also say there are specific inline scripts that we trust. So we've got self, code.jquery.com, and we've added a nonce. And that's going to allow our inline script to run, which we can see here. We've logged to the console that our inline script ran. So now we've got attacker script blocked, inline attacker script blocked, and our own inline script running. So let's look at what that inline script actually is doing. It's right here. So it's just a normal script tag, but we've added a nonce attribute, and that has to match what we've got in our HTTP header. So nonce-5415 whatever, 5415 whatever. So you just give it a random string both in the header and on your inline script. And that tells the browser, hey, this is trusted code versus attacker code. So you could do that per request, just generate some random bytes, and unless the attacker can guess that random string, they're not going to be able to run their code. So that's the next step. Now, one pattern we've talked about a lot in recent code reviews is the inserting of data into a DOM node. So we talked about this last week with the encode JSON HTML safe, where you have a global variable in your initial DOM, you assign some JSON to it. That works really well. It gets over some of the problems with heavy client-side apps having to do multiple round trips to get their initial data. But you're doing an inline script in that case. And unless you're doing that nonce that we showed in the last step, that's going to break on content security policy. An alternative to that, and one that I think is actually really appealing once I started thinking about it, is using a script tag with a different type. So in this case, we've got application/JSON and an ID. And inside that script tag, we just have our encoded JSON data. So we've got this little block of data here. And our js/app.js is just logging that data. So that's all we're really doing with it right now. The reason I find this really appealing is, one, with content security policy, it doesn't care about script tags with different types. It'll skip over them because they're not going to be executed. So right there, you don't have to worry about doing a nonce or anything like that with these tags. Additionally, though, you're saying everything in the script tag is not executable. Whereas the way we were doing this before, where we would say like var global variable name equals some JSON, you're still in a context where the browser is expecting to execute code. So if you mess something up, code will execute. If you mess something up inside the script tag with a different type on it, code's not going to execute. The browser doesn't care about this at all. It's just kind of a data block. So in this case, I've added a little view helper that does this for you. So we can see this being used in my view script here. I just say echo this JSON data, give it an ID so that I have some way to get it out, and then the actual PHP value that I want encoded as JSON. In the JavaScript, right now I didn't install any libraries beyond jQuery or anything, so this is how you would get that data back. You know, I'm just getting the DOM node and then saying give me the text inside of that DOM node and parsing that as JSON. I think if we were going to use this pattern more, you know, I would put a little helper into the main dewdrop.js so you would be able to get that data without saying JSON.parse and so on. And this view helper, I think, will end up in Dewdrop itself. So you can put this data out for the initial DOM without it being possibly interpreted as code, which I think is a nice advantage. And really, it takes advantage of the fact that, you know, JSON, while it does evaluate as JavaScript code, you know, that's one of its big advantages over XML and so on, is that from a JavaScript context, it's very easy to work with. And before real JSON parsers existed in the browsers, you could just eval it and you would get your value back. So that's a nice aspect of JSON from an adoption standpoint. But really, it's supposed to be data. It's not supposed to be code. So passing it to things like JSON.parse and putting it in a context where the browser knows it's not JavaScript code, I think is a big win security-wise. If you're explicitly saying, hey, this is not supposed to be executed. So that's the point of this step here. And then finally, the last feature of the standard itself I wanted to point out is there's actually a reporting concept built into the standard. So this is our header at this point. We're saying where we allow code from. That's the script source portion. But we've added this report URI portion of it. So whenever content security policy detects a violation like this now, it does a post to this URL. So if we look at that in our network tab, we see that there are two posts going on here to that URL, and the payload or the body of the request is information about the violation. So it tells you what was blocked, where it was blocked from, what directive from our HTTP header was involved and what was violated, and so on. So you can see exactly where the cross-site scripting vulnerability happened. And one thing that's kind of interesting with content security policy is you can actually set up a header that says, don't enforce this policy, just report on it. So you could put this on a site just as a way to detect when cross-site scripting is happening. So whenever there's a script that's loading that I don't expect, send a report to this URL. So you could set that up on your site at first just to see, okay, what does my header actually need to look like? What third parties am I using code from on a regular basis? And then once you've got all of that handled in your header and you're not getting violation reports anymore, then you could start enforcing it. And then any violations that you hear about from that point on are indications of real cross-site scripting vulnerabilities. So obviously, with that post, you could do whatever you want to do. You can log that a million different ways. I've got a very simple example here of just taking the request body from Symfony, writing it out to a file. So whenever someone has a cross-site scripting violation now, that it shows up in my log file here. So I automatically get that. But you could throw it in monologue or whatever you want to do in order to get email notifications, that kind of thing. So that's the reporting aspect here. In general, what I would like to see us move toward is on newer stuff, writing our code in such a way that we can get by with this content security policy header. And that means no inline scripts. It means no third-party scripts loading from someone else's server. So really tightly controlling that stuff. So you would pass some data using the non-executable script tags that I was showing before, the text/JSON or whatever you want to do. You would load files from your server only, and then you could pull that data in if you needed to from the DOM, but anything other than this would just be blocked. Now, you could maybe have a third party or two if you wanted to pull like some Google JavaScript directly from their servers. I would be okay with that, putting that in the header here. And then on some older applications that are very reliant on having inline JavaScript, the nonce feature of content security policy, I think, is a viable option there. The biggest example of that would be SWAT. So SWAT relies pretty heavily on inline JavaScript snippets to kind of hydrate widgets inside the browser. The only thing you would really have to do to make all SWAT widgets compatible with it is patch this display inline JavaScript method, which is in swat.php. So it's kind of the core SWAT file. And you would just add the nonce right here. So that would automatically make SWAT compatible with this in full on those older applications. On newer stuff, though, like I said, I would prefer to not even bring that kind of fallback into play if we can avoid it, and just do what is allowed in the strictest form of this policy. So I definitely am going to put this in place for Total Care Health, but I also want to experiment with doing this on Graph. I think in the case of the Graph site, I'm going to start with the non-enforcing policy that just reports what's going on, and then we'll kind of fine-tune it as we go along from there. But I thought this was a pretty cool web standard that, as far as I know, we're not really using anywhere yet, that really makes cross-site scripting a much easier thing to handle. Like from the server side of it, we really only get the big text block that we're sending down to the browser. So we just get, this big string that we're sending down. And it's really hard to get that right. Like if you make one mistake, then you've got major cross-site scripting problems, and your app is going to have all kinds of issues. From the browser standpoint, though, they can actually say, I don't care where this code is. It could be inline script. It could be the window.opener thing that Ray was sending around the other day. It could be the attribute event handlers that you put on DOM nodes directly. It knows when JavaScript code is being executed, regardless of where it came from. So it can very easily block these things for you. So I think this is really putting the cross-site scripting protection at the right layer. On the server side, you can do some escaping, and we should, but it's too easy to mess up. At this layer, it just seems so much easier for the browser to get it right if you're willing to follow these slightly stricter rules. So I personally think this is very cool standard. Any questions?
Brad, do you have a recommended format or way of generating that nonce value?
Yeah, in general, for PHP, the thing that you should rely on for getting randomness at this point is this function random bytes. This is built into PHP 7. There's a compatibility fallback for older versions of PHP, as you can see here. And this automatically chooses a good source of entropy for your randomness. So you can see here on Windows it uses cryptgen_random, on Linux the getrandom syscall, and then it'll fall back to dev_urandom on other Unixes. So this gets you good randomness, and then all you have to do to make it more usable in a webby context is use typically the bin to hex function in PHP. So let's hop into a shell real quick. So do vendor bin, do drop tinker. So if we just do echo bin to hex, random bytes 20, that gets you a nice random value you can work with. And the number of bytes can just pretty much be determined by how long of a string you want to work with. In this case, it is an HTTP header, so you don't want something too long because you do have some length restrictions there. But I think that would be a plenty difficult to guess string right there.
And hard code that nonce into your code, or would you generate it on a per page load basis?
Yeah, I would do it per request. That way, the attacker can't really look at it and just code that into their exploit. Now, in most cases, I think if you use that nonce at all, even if it was hard-coded, that would be enough to scare away your typical script kiddie doing a cross-site scripting scan of some kind. But if you actually had someone trying to attack your site, it would be better to do the per request random string.
All right, I got one more.
Cool.
That post request going to your reporting URI, is that coming from the user's browser?
Yeah, that would be coming from the user's browser. So the idea there is you're primarily protecting against like a reflected cross-site scripting attack. So going back to the total care health example from the beginning of the session here, a patient who is maliciously trying to get doctor's user credentials so that they can look at other patients' information, and a medical record system would put some script in the symptoms box when they're signing up for an appointment. The doctor then goes to look at that appointment request on their side while they're logged in, and they're running that script. The content security policy would block the attempt to run that script and send the report to your URL. So that's how you get notified that the browser actually blocked something in violation of the policy, or at least detected something that violates the policy if you're not in enforcement mode.
Hey Brad, is this something you could set in like an htaccess file, or is this something you would need to do in like a PHP view?
Yeah, you can set a header in an htaccess file. That's perfectly fine. Depending upon how Nginx is sitting in front of that, you may want to set it at the Nginx level. But yeah, at your web server level, you could certainly set an HTTP header. The other option you have is you can do an HTTP equiv meta tag in your HTML to set this. That works. The only problem with doing it via the HTML is the report function does not work in that context. So you can still block things without having any access to the server at all, just a static HTML file, but you can't do the reporting feature.
Gotcha.
I think
Cool.
Nginx will forward those on.
Okay. Cool. Because I mean, for like, I guess small projects, I think just setting that in one place just via HD access will be a lot easier. You would just set it and don't have to think about it.
Yeah, that's certainly the case. You would want to do this in a place where you could get away with doing it once. So in the context of like a Zen framework app, you could get the request object and set the header there. Or in most PHP apps, you could probably put a header call somewhere in like your bootstrap phase to just say, hey, I want to set this HTTP header. And then whenever the response is sent, that'll be set for you. So it should be a one-liner if you're able to comply with whatever the policy is that you set. All right, so this demo app is on GitHub. It's pretty simple. I mean, it's a Dewdrop Silex skeleton app that I threw a couple of little pages in. So there's the home page that links to different stuff, and then the example page that actually has the exploits and so on. So that's available if anyone wants to play with it. And then, like I said, the two areas I think this is going to pop up right away are Total Care Health and Graph and Sons. So there'll be a little bit of work there. And really, if anyone wants to help with that, I could give you some pointers on the types of things that need to be done, you know, like that little SWAT patch or getting rid of some inline scripts where that's possible, that kind of thing.